Hello everyone, welcome back to our college algebra course this semester. Today I'm gonna cover the last two sections of chapter 4, section 4.3 and 4.4. It's all about quadratic functions and their graph. So in section 4.3 we're gonna show you some basic definition and basic properties of quadratic function, and then the next section 4.4 I'm going to show you some word problem, some application of quadratic functions, okay, using quadratic function. So let's start. First, I'm going to give you the definition. A quadratic function is a function, of course, a function of the form ax squared plus bx plus c. Let's box it so make it stand out. Okay. Right in here. A, B, C's are numbers. In our class, it's the real numbers. Okay? A, B, C's are numbers. Actually, we have a name for those numbers. We call them the coefficients. Just numbers. Okay? And the number A right here in front of x squared, it has a special name because the leading coefficient. Leading coefficients. Okay? And we do have condition for A. A needs to be non-zero. Excuse me. You guys see why we need A to be non-zero? See, what happens if A goes 0? Then you don't have the x squared term. You only have what, bx plus c, and we don't have quadratic function anymore. It turned out to be what? A linear function, bx plus c. Okay? That's why we need the leading term to be non-zero. Okay. Example. We have something like f of x equal to 5x squared minus 4x plus 1. So this is a quadratic function where a is 5, b is negative 4, and c is 1. Or you may have this about g of x equal to negative x squared plus 7. Here, a is negative 1, and b is 0, and c is 7. You can think of it as negative 7x squared, negative x squared plus 0x plus 7. But usually people don't write 0x, so just negative x squared plus 7, and this is another quadratic function. Or you may have like h of x equal to 2x squared. Means what? A is 2, b is 0, and c is 0. Okay? That'll be okay. As long as you have the a term, the leading coefficient non-zero, you have a quadratic function. Alright? And that is the definition. Now let me move on to show you some basic, very basic properties of quadratic function. So you see what it means by quadratic function. I bet many of you guys seen this before. Just got three things in here: the x squared, the x, and the number term. Okay, and along with the number, those numbers called the coefficient. Okay, and the leading coefficient, the number in front of x squared, cannot be 0. All right, let's move on to next item, number 2, some basic properties of quadratic function. The very first one, I'll be talking about the graphs. Graph of quadratic function, it has a name, it's called parabola. Okay. There are two types of parabola that you may see. A function will be oriented this way, it's upward parabola or downward parabola. Depends on the sign of the leading coefficient a. So if a is positive, parabola tends to be upward. A is negative, then parabola will be downward. And of course, we never have a equals 0. Okay, a equals 0, we have a straight line. Graph will be a parabola. Okay. Next, second, talk about the second property, number 2. We'll be talking about something called the vertex of the parabola. Actually, the vertex is a very special point. I can use the same graph right here, so I don't have to draw it again. Vertex is the point right there. It's called the vertex. That's the point. So if the parabola is open upward, the vertex will be the lowest point on the parabola. And other way around, if the parabola is downward, then the vertex is going to be the highest point on the parabola. Okay. And let's denote the vertex by V. H comma K. This is a point. V stands for vertex, and then H is for the x coordinate of vertex, and K is for the y coordinate of vertex. And I claim that we can calculate H and K if you know the quadratic function. Okay. So in general, if you have f of x equal to ax squared plus bx plus c, quadratic function in general, and graph parabola, we know this already. Then the vertex can be calculated this way. H will be negative b over 2a, negative b over 2a. And keep in mind that a is non-zero already, so you're okay to divide. And then after having h, you plug into the function, you can calculate k. K is equal to f of h, which is f of negative b over 2a. And you have the answer. Example. Say f of x equal to x squared minus 4x plus 3. And you see that this is a parabola. Is it upward or downward? It's going to be upward because the leading coefficient a is equal to 1 in here, which is a positive number. So upward. And I'm going to show you how to calculate h and k, which is the vertex. H is equal to negative b over 2a, which is negative of negative 4 over 2 times 1. B is negative 4 and a is 1. This is 4 over 2 equal to 2. After having h equal to 2 already, you can calculate k by plugging f of 2, which is f of 2 right here. So it's going to be 2 squared minus 4 times 2 plus 3. So 4 minus a plus 3 equal to negative 1. Okay, so let me show you the graph of this function. The graph is going to be like this. Use a different color, make it stand out. The graph is going to be like this. Okay. The origin is right here. The vertex is at 2, negative 1. And I know the parabola is upward because a is 1. All right. Graph is going to be like that. Vertex is at 2, negative 1. Oh, by the way, let me use this opportunity right here to mention of a technique you guys are going to use to draw a graph in my math lab. Say you have an equation in my math lab and you want to sketch a graph of that thing. You're going to find two things. First, you find the vertex, which is right here. And second, you find any point on the graph. Usually people use the y-axis to any points, okay? So you plug the x equal to 1, you can find another point. I plug the x equal to 1, I got what? X is 1, y 0, okay? So when you graph, right, on my math lab, you just hit the graph box, you see a bunch of boxes, you choose a box with a parabola symbol like this, I think. It's on my math lab. You click on that, this indicates what? You have to click on 2 points, right? So the first point you click on is the vertex, you choose vertex, and then it's going to show you the graph, and then choose another point. So I plug in x equals 0, I got the point 1. X equal to 1, I got 1, 0 is another point on the graph. Okay? So, to graph the parabola on my math lab, click on the parabola symbol, and then you see the graph, click on the vertex and another point on the graph. You will have the parabola. Okay. Sorry, I'm using the whiteboard right here, so I cannot open my math lab. That was the idea. Okay, so that's about the vertex of the parabola. Next, I'll be talking about another thing called the axis of symmetry. Number 3, axis of symmetry. In general, doesn't matter if parabola is upward or downward, parabola will always symmetrical about a vertical line. And this vertical line called the axis of symmetry. Axis of symmetry. Okay. Always go to the middle point of the parabola. Of course, that point is going to be the vertex. You know that, right? Now, this vertical line is the axis of symmetry. And recall what we learned before in the equation, the vertical line is always x equal to a constant. Since the point right here is v hk, right? It's always v hk, the vertex. So x coordinate is always h. So the axis of symmetry's equation is going to be x equal to h, which is negative e over 2a. So the equation of the vertical line always x equal to h. Okay. So in this example right here, the axis of symmetry is x equal to 2, because this is 2 for the vertex. For the x coordinate, Okay? Axis of symmetry is just the vertical line. Imagine that you cut the graph into two halves. The left half and the right half always reflect each other about the axis of symmetry. Okay? That is about the axis of symmetry. Now let me talk about the intercepts. Number 2, number 3. How about number 4? Intercept. We have two types of intercept. We have the x-intercept, the y-intercept. Let me use an example right here. Well, I think the name said intercept is a point where the parabola intersect either the y-axis or the x-axis. Okay? So how do you want to find the y-intercept? So let's talk about y-intercept. To find the y-intercept, you let x equal to 0, right? Excuse me. Let x equal to 0, you can solve for y. Y-intercept, let x equal to 0. So in this particular example right here, where was it? Oh, right here. I'll let x equal 0, so the y-intercept is 3, which is the c value always. Right? Let x equal 0. So, what? Let me write in general, okay? F of x equal ax squared plus bx plus c. So f of 0 is equal to a times 0 squared plus b times 0 plus c, which is equal to c. So the y-intercept is at 0, comma c. Okay. This is a point. That's how I write this way. In this example right here, obviously c equal to 3. So this is the y-intercept at 0, comma 3. That's the point. And I claim, even though I write that long, but actually you don't need to do any work to find the y-intercept, because just look at the number c at the end and you see the y-intercept right away. Okay. And second, talk about the x-intercept. Now we have more things to talk about intercept. What do we need to do? You let y equal to 0, right? Let y equal to 0. In this particular example, you may have 2 x-intercept. And depends on the orientation of the graph, you may have 1 or no x-intercept at all. So let y equal to 0. See what we have. So y means f of x equals 0, then you have what? 0 equal to ax squared plus bx plus c. And you have to solve for x from here. And we have a very famous and popular equation called the formula called quadratic. Use quadratic formulas. Quadratic formula. And the quadratic formula says this: x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. This quadratic formula is boxes. Okay. And I claim that for quadratic function you may have 0, 1, or 2 x-intercept. It is depending on this quantity right here. Now this for the discriminant, I think. Okay, discriminant. And denoted by delta equal to b squared minus 4ac. So let me just show you the graph and you'll see what we're talking about. Assuming that we have an upward parabola, same way for a downward parabola. I'll just show you upward first, okay? So this is my parabola is completely above the x-axis. You will always have the y-intercept right here, but no x-intercept, okay? So if you shift it down a little, we learned about graph transformation already. If the parabola just touches the x-axis, you will have exactly one x-intercept, and this will always be your vertex, okay? The other case around, you move the parabola a little bit lower, then you're going to have 2 x-intercepts. Okay? And the vertex is down here. On all 3 cases, keep extending the parabola all the way to the left, all the way to the right. Guarantee that you will always have a y-intercept. But you may have 0 or 1 or 2 x-intercept. And it depends on the case right here, the discriminant right here. Because you have a radical square root, okay? So if, which is delta. If delta is a negative number, so you have a square root or negative number, so you have no x-intercept. negative 9, no real solution, no x-intercept. If delta is say equal to 0, you have 1 x-intercept. Say the square root of 0 is equal to 0. Okay? And the intercept right here is the vertex. Okay? And if delta is positive number, then you have 2 x-intercept. And those are the 2 points. Because say think of it like square root of 9. Square root of positive number you have with a plus or minus outside. And this one you're gonna later on if you learn about in complex number, imaginary number, this is gonna be 3i, and it's not real, so you have no real solution, no x-intercept. 0 right here, you put a plus or minus in front, it's still 0, so we have 1 solution. And the square root of 9, I'll just give you 9 as an example of positive number. Could be any positive number in here. Okay, square root of a positive number, say square root of 9 plus or minus, give you 2 solutions. Okay, so let me give you an example. I'm going to use the same example that we had before. Say we have f of x equal to what? X squared minus 4x plus 3, and I know the y-intercept is at 0, 3 already, right? For x-intercept, I let y equal to 0, so 0 equal to x squared minus 4x plus 3. And I claim that some problems you may use something called factoring. Okay, I claim that only if you have a nice coefficients, nice number is factorable, then you can see the x-intercept quickly. But most of the time, it is impossible to factor, or it's really hard to factor and make it that way. Then you really have to use the quadratic formula. That'll be that'll be a safer way to find the x-intercept. So this is what, if I factor, I got x minus 1 times x minus 3, then I have 2 x-intercept, x equal to 1 and x equal to 3. But let's try the quadratic formula, okay? X equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Plug in the numbers, I got negative of negative 4 plus or minus square root of negative 4 square minus 4 times 1 times 3 all over 2 times 1. Negative 4 right here is, let me write up here, 4 plus or minus square root of negative 4 squared is 16 minus 12, and all over 2. Oh, I write 2 too high, right? So that was 4 plus or minus square root of 16 minus 12 over 2, and this is up here. What? 4 plus or minus square root of 4 over 2, which is 4 plus or minus 2 over 2. You have what? 6 over 2 equal to 3. So this one is what? 4 minus 2 is 2 over 2 is equal to 1. So you have 2 solutions. Okay? So for x-intercept, you have what? Either 3, 0 or 1, 0. As you see in the graph. This is the case right here. Alright? That's about the x-intercept and y-intercept. For y-intercept, let x equal 0, you have the answer. For x-intercept, use quadratic formula. Okay? Or sometimes if you're lucky, then you can use the factoring method. Good? Now, let's move on to another form of quadratic function. So far, I introduced to you this function, f of x equal to ax squared plus bx plus c. That's called the general form. Okay, the general form. General form of the quadratic function, and we use that as a definition. Now I'm going to show you another form. So number 2 was property, right? How about big 3? Standard form. Quadratic function can be written this way. F of x is equal to a times x minus h squared plus k. And all the letters are familiar. A here is actually the leading coefficient. Let me box this one first. Okay. A here is a leading coefficient. Of course, this cannot be 0. Leading coefficient. Gonna be exact same A that you have up here. Same. And what are H and K? H and K are the coordinates of the vertex. So V, H, K is the vertex. So if the quadratic function is written in this form, then what? You can determine right away whether the parabola is upward or downward by looking at A, and you can find the vertex right away. So let me give you an example. Example. Say f of x equal to 3 times x minus 2 squared plus 4. So in this example, A is equal to 3. Leading coefficient positive, parabola is upward. And the vertex is at 2, 4. You see? Minus 8, so minus 2 right here, so H is equal to 2. And then plus K, so K equal to 4. This is my H right here, and this is my K right here. Okay? Or you can have another example. F of x equal to negative of x plus 3 squared plus 2. So in this example, A is equal to -1. Put that negative right here. Okay, so you know the parabola is going to be downward. And what about the vertex? Vertex is going to be at -3, 2. Because the opposite of h right here, think of it as x minus -3, which is plus 3. So h is -3 and k is 2. And that will help you to find the vertex as well. Okay. There's one type of question you may see in the homework is how to convert back and forth between the general form to the standard form. Let me give an example. Say f of x equal to x squared minus 4x plus 3, right? There is a method. You can look it up in the book called what? A completeness square, but I'll show you another way, which I think is quicker. Say you have the general form right here, and I want to find the vertex form. So what do I need to do? I need to calculate A. A in here is 1, right? Leading coefficient. I need to calculate H and K. This one, H, the vertex coordinate. So H is what? Negative A over 2A, which is negative of -4 over 2, which is 2. And then I can calculate K, which is f of 2, which is 2 squared minus 4 times 2 plus 3, 4 times 2. Plus 3 is equal to -1. We did that already. I just rewrite it. Okay? So I can find from the standard form, starting from general form. So what? I got f of x equal to a times x minus h squared plus k, right? All I have to do is fill in a number, which is what? A is 1, so I don't have to write 1. Let's just write here first. X minus 3 squared and then plus -1. Or simplify, this is x minus 3 squared and then minus 1. You have the answer. Okay? So you have the general form. You can convert it back to the standard form by calculating the vertex, H and K. And we know how to calculate the vertex already. And leading coefficient A is given. You just plug them in. You have the standard form. Another way, which is more formal and which is very powerful, and I think it's useful too. Later on, when you guys move on to pre-calculus, it's going to be helpful. It's called completeness square technique. Completeness square. Okay. So what do? You have just one x squared. You do this for me. X squared minus 4x and then plus 3, right? And this is what you do. You're going to add a dummy 0. Half. Take a half of the b term right here. Half of this. Half of 4. Doesn't matter 4 or -4. Just take half of it, which is 2. Then square it up. Half of 4 is 2. Okay? 4, half of it is equal to 2. Square the 2 up is 4. So plus 4. Always add first and then minus 4. So this is just 0. I didn't change anything. I just simply add 4 and subtract 4. And that always gives me a perfect square. The first 3 terms right here will give me a perfect square of what? X minus 2 square, and all I have to do is combine the like term. Minus 4 plus 3 is -1. See, I got a perfect square. This is called completeness square technique. Okay. Another example of completeness square techniques that may or apply to a more general case, I got this f of x equal to, how about 2x squared plus say 12x minus 7, for example. Okay. The difference between the second example and the first example is that the leading coefficient is different from 1. Could be anything, right? So first of all, you need to factor out whatever it is. So 2. I got what? X squared plus 6x, right? X times x, 2 times x squared is 2x squared. 2 times 6x is 12x. Then leave some space right here.